Let's analyze the motion of a batted baseball. The ball leaves the bat with initial speed 37.0 meters per second at an angle of 53.1 degrees above the horizontal. We'll ignore air resistance and use projectile motion equations. Given initial velocity 37.0 meters per second, launch angle 53.1 degrees, and we'll analyze at time 2.00 seconds after launch. First, let's find the components of the initial velocity. The horizontal component is versus 0x equals versus 0 cosine theta. And vertical component is versus 0y equals versus 0 sine theta. Calculating. V0x equals 37.0 times cosine 53.1 degrees equals 22.2 meters per second. And versus 0y equals 37.0 times sine 53.1 degrees equals 29.6 meters per second. Now for part A. Find the position and velocity at t equals 2.00 seconds. Using the projectile motion equations. Horizontal position x equals versus 0x times t equals 22.2 times 2.00 equals 44.4 meters. Vertical position y equals versus 0y times t minus 1/2 gt squared equals 29.6 times 2.00 minus 1/2 times 9.80 times 4.00 equals 39.6 meters. For velocity, horizontal component remains constant at 22.2 meters per second. Vertical component Vy equals versus 0y minus gt equals 29.6 minus 9.80 times 2.00 equals 10.0 meters per second. The magnitude of velocity is square root of 22.2 squared plus 10.0 squared equals 24.4 meters per second. The direction is arctangent of 10.0 over 22.2 equals 24.2 degrees above horizontal. Now part B. Find the time and height at the highest point. At the highest point, the vertical velocity becomes 0. Set Vy equals 0. V0y minus gt equals 0. So t equals versus 0y over g equals 29.6 divided by 9.80 equals 3.02 seconds. The maximum height h equals versus 0y times t minus 1/2 gt squared equals 29.6 times 3.02 minus 1/2 times 9.80 times 3.02 squared equals 44.7 meters. Part C. Find the horizontal range r when the ball returns to ground level. Set y equals 0. V0yt minus 1/2 gt squared equals 0. Solving this quadratic equation gives t equals 0 launch and t equals 2v0y over g equals 6.04 seconds. The range r equals versus 0x times total time equals 22.2 times 6.04 equals 134 meters. When the ball hits the ground, The vertical velocity is negative 29.6 meters per second. Same magnitude as initial but downward direction. Now let's plot the trajectory to visualize the baseball's path. Let's evaluate our results. The maximum height of 44.7 meters is comparable to the height of a baseball stadium roof. And the range of 134 meters is greater than the distance to the outfield fence.